So I hope you're not tired or too tired, and thanks for still being here. I'm Portuguese, but I work for a Dutch company, the Software Improvement Group, and the headquarters of SIG are in Amsterdam. So I'm gonna tell you about the company and what we do, because they are sponsoring me to be here. And when you tell your boss that you want to go to a conference in Portugal, and he says, what do you want to do there? You have to justify the budget and the money you're spending. So, but this is a nice company, and the things we do are very nice. So basically what we do is we look at software, and we measure software quality by helping people improving their software quality. So we have models based on the 25010 ISO standard, and among these models, we look at the maintainability of the software in the long term, but we also look at security, reliability, performance, and other properties. So we evaluate all these things, and we give advice to our clients. So basically, we are a consultancy company. I'm not a consultant formally, although I do some consultancy. I'm a researcher, and I have a background on many things and nothing at the same time. So I did a PhD in formal methods related with cryptography, and then I'm working on security right now. So this is a bit. There's no direct trail of my knowledge, and I jump from different areas in the same related areas at the same time. So I want to know what you expect from this talk. Do you have any expectations? So how many of you know what is a SQL injection? How many of you did a SQL injection? Okay. So this is very familiar to you, I guess. So this is what we do when we evaluate a software system. I forgot to tell something. We have a lot of software. What we get from our clients is source code. We have a huge database. I cannot say that it's the biggest database in the world, but we have a huge database of proprietary software from our customers, and what we do is to look at their software. So, as you know, to develop secure software, you have to be systematic, and you have to follow some guidelines of secure software development. And this starts with training. So all the developers should be trained for secure coding. And then when they start developing their product, they should start by defining the requirements. What are the security requirements of their system? And then they start a design, coding, and then they need to verify that their software, the code that they implemented, verifies the requirements that they initially defined. And something went wrong. So when you deploy your software, something is not right, and you don't know why. So that's where we help our clients, and they always come to us like, what did I do wrong? Where is my problem? How do I do this right? So the question is, oops, where does this fail? So this is my theory, and maybe this is right. So all the developers have a training. They're all trained, and then they have to define the security requirements. And what we usually find is the software needs to be secure. What does that mean? No one really knows. And then because of that, so you say your software needs to be secure. Okay. they fail to identify their threats, their vulnerabilities, and their risks. So they cannot mitigate their vulnerabilities. But they continue and they start developing their software with the functionalities, and then they need to do something because the software needs to be secure. So what do? They build security as an overlay. And they try to do tests or not. So people usually fail in testing the security requirements. They do proper unit testing of the functionalities. Not all the time, but sometimes. But for security, we don't see any testing. Even pen testing. Some of our clients don't know what pen testing is. So, and this happens, right? So you are on the news, you have a data breach, and you fail to deploy on time. So this is just blah blah blah, or it seems so. But what do we do in reality? How do we help our clients? So basically, we get a lot of code, we look at the code, and we try to find the vulnerabilities in the code. It might seem easy, but it's not, because developers are really imaginative. They come up with the most interesting things you can imagine. And sometimes it's a very, very hard task, because frameworks are different. So now there's a lot of hype frameworks, Angular, React, everyone uses a different one. And these things together with the backend languages, becomes complicated to analyze because they like to do tricky stuff. And that's what I'm going to tell about. So what do we do when we do secure code reviews or software inspections? How do we code? So we ask for the requirements because we look at the whole picture. We don't look just to the software. We need to look at the whole picture. So we ask for the requirements, the design of the system. We ask for the source code. We ask sometimes for a demonstration of the system because we need to understand what is happening. And we try to understand how is their secure development process. But we don't get all this information. So we can always get a demo because the system works, and we get the source code. And we get some information of the development process, but that's all. No requirements and no design for security. So what do we see in the code? It's not just white. It's not that we don't see anything. So we see good things. So this is it's not that everyone does the same, or there's like 100% of people do exactly the same. That's not true. But we see some good things happening. So most software developers know what they have to do. We see some bad things, and we see also some ugly things. So what do we often find as the best practice? So everyone knows what is a SQL injection. So everyone knows how to mitigate it. So everyone uses parameterized queries. But I believe that there's a reason behind this. Not because the developers want to use to validate their inputs to use parameterized queries, but because all the ORM frameworks that are provided nowadays parameterize the queries. The other thing we always see is that because they use these hype frameworks nowadays, these front-end frameworks already have some embedded security, we always see data in the front-end being validated. So you can't do a cross-site scripting on the browser side. You can't do certain attacks on the browser side because these frameworks already provide you some security. They also implement authentication correctly. And this is because this is a security requirement often. So you want to input login and password. And there's a mechanism to implement this in the correct way. So they always use filters, and this always works for them. Usually, so now everyone knows that the communication needs to be secure, so everyone uses HTTPS, TLS 1.0, 1.1. Not always the right one, but they try to protect their connections. And they keep the cipher suites that are the default ones for the web server, which sometimes is a bit dangerous. So they use security frameworks. So Spring Security, Spring Boot Security is always used, and this provides some additional security level or increased security level with low effort from the developer side. And they don't try to show exceptions directly to the user, or they try to avoid this because they know that printing stack traces or exceptions directly on the browser, it's a bad practice. So they are doing good stuff. At least the clients we have seen. We haven't seen the whole world, but there's things we don't find, and these things are actually very easy to implement. So it sounds weird, but most of the times, all the HTTP headers that enforce some level of security or make your application more robust are missing. So cache control, they don't prevent cache. Secure cookies, there's very few developers that actually use correct flags for cookies. So access control, so everyone knows what authentication is. So login and password, and you block the user from entering. But what about permissions? Are you allowed to execute certain functionality in the system? Are you not allowed? So this part is always very complicated, implemented in a very ad hoc way, and is sometimes done in the wrong part of your system. Session tokens, so they should use the default session manager of the framework they are using. But sometimes they generate cookies that are based on user data. For instance, the username. They hash the username, and that's the cookie. So log files, they never contain the information that is necessary to perform a proper audit afterward. And connections in the backend, so everything is protected. So your external network uses secure connections, but the internal network is completely open. And this is this could be acceptable if your users are not inside the same network. So if you have everything in the same network and you don't protect the connections, then it becomes a big problem. So what we always see, and this is a huge trend nowadays, I don't know why, it's hard-coded passwords. So everyone uses the same password all the time to encrypt the data. And these passwords are sometimes in the clear in configuration files, which is already a bad practice, but sometimes you find them in the code. So meaning, when you patch this code, the code goes with a password that was created by the developer. And if you try to reverse engineer this code, you can easily see the password that is used to encrypt the data. One other thing that we often see is that developers don't know how to use crypto libraries. And there's many reasons for this. I believe that the main reason is because crypto is hard, and there's no guidelines on how to use how to properly use a crypto library. And I'm not going to continue, But what we see is that most of the vulnerabilities of the software of our customers is because the libraries they use have vulnerabilities. So you cannot build a secure software without checking that your dependencies, if your dependencies are vulnerable or not. So one of the things I think it's very, very critical, it's the access control problems that exist in the software systems. And the reason I believe that there are so many problems with permissions and checking permissions in your system is because they don't centralize the access control and they don't define it in the requirements phase. So this always starts in the beginning. So that's why I showed the secure development lifecycle. Because if you don't develop in the beginning, you don't start developing in the beginning in the right way, then you will never be able to implement your software in the right way. And what we see sometimes, so we see customers implementing access control policies on the front-end application, so on the browser side. And this is very nice. But what happens is, most of the applications nowadays expose a REST API in the backend. And if you don't protect your REST API, you can easily bypass all the authorization mechanisms. Besides that, loading all the content to the browser leads to a lot of data breaches. So another thing we always see is mixing development code with production code. So the production code that is patched, is released, has a lot of development code. And this is a good way of introducing a backdoor in your system. So you remember the go-to? So maybe this is an example of what happened there. And we see a lot of misconfigurations resulting from development code that is embedded in production code. And what we always advise is that cleaner code is safer code. So, how comfortable are you with crypto? Are you like that guy that is gonna run away? So crypto is a problem in the development in the real enterprise software. And back in 2006, Chris Eng, I think he's vice president of Vercode nowadays, identified some crypto mistakes and presented a talk explaining how you could use these crypto mistakes to exploit the software. And one of the things that he mentioned is that on that time, 2006, so almost 10 years ago, there were a lot of homegrown algorithms. So people, instead of using the standard algorithms for crypto, they were implementing their own. And of course, this security by obscurity is not security at all. So the other thing that he pointed out is you could be using a block cipher, but with insecure modes of operations. Also, there were some poor key selection, and the key length was not big enough, and it was reused. Random number generation was never used, or it was used in an improper way, and the correct use of the crypto API was not being performed. So what we see over these 10 years, so in 2006 I was even not finished, I didn't finish even my bachelor, so I didn't really know about crypto at the time. And what I see that happened in 10 years in the enterprise world is that most of the developers don't use homegrown algorithms. And they use recommended key lengths. But everything else remains the same. So we still see a lot of incorrect usage of crypto. And the question is, where does the problem lie? What's the problem of not developing secure software? I believe that sometimes when you train the developers, the training is not effective. So you go to a training of 1 week, you have no background on security, you have no background on crypto, and you have to become an expert after 1 week on security and on developing secure software. That doesn't work very well. The other thing is security is a very difficult concept to grasp. So developers are in the dark. They can't see anything. They try to do things, but sometimes it's hard. So they try their best, but they fail because it's hard to understand. And the other thing we see is that there's no requirements. So defining that the system is secure is not a requirement. You have to specify what do you want to enforce. What is the security requirements of your system? And because of this, so they don't have any clue, most developers go to very well-known forums and try to understand how to use crypto, how to implement security in their software. And these forums sometimes, or most of the times, have a lot of insecure examples, but because you don't know what's the correct way, you cannot judge whether it's insecure or not. And the other thing is, these frameworks and libraries that you see that are used and nowadays have a lot of embedded security, sometimes have the defaults. Have defaults that are not secure, and there are many reasons for that. But I think this is a big problem, because if you tell a developer, use this library, your software is going to be secure if you do this, this, and this, but you don't change the defaults, then you have a problem. And developers don't read the documentation, or sometimes the documentation of the libraries is not available, or it's not clear enough. So if we go back to the beginning, I think that the problem fails in the beginning. So not when you have training, but when you try to start developing the system, and when you define the requirements and the design. So if you don't define the requirements, then you can never identify your threats and vulnerabilities. So you can never mitigate them. And then when you try to deploy your system, or to verify and test your system before you deploy it, you have to test it. And what we see is, so static analysis tools and dynamic analysis tools are rarely introduced in the pipeline of the development of a system, only if the company has is a big company and has a very mature software, a secure software development. And sometimes clients don't know what pen testing is, which is a bit dangerous, because we think, come on, how come you don't know what you need to do to improve your system security? So that's it. I promise to be short. I don't have that many things to say. I just wanted to present the idea because I was sponsored to come here, and what we do is look at software. So we wrote a book about building maintainable software. So we have 10 guidelines on how to write software, and I only have 3 copies in C#. So if you want a copy, you can take it afterwards. But you can also, if you're on GitHub and you want to have your code checked for these 10 guidelines, it's free, and you can use the Better Code Hub, which is a platform that tells you how maintainable it's your software. It's not free for enterprise software, but if you have an open source software, you can use this for free. So that's it. If you have questions.
have a question. So, do you do threat models as part of your flow then? Where does it fit?
We do. So we also do threat modeling as an initial part of the analysis and development. But what we mostly do is code reviews, because by the time we get the client already has a system that is being developed. So the client wants to pen test the system, but they want to know what are the insides of the system, or the client has another external company developing the system, and they don't know how the system is being developed. So most of the times we do secure code reviews, but we also do some threat modeling analysis for.
How do you communicate secure code review findings? So when you find stuff on the code, how do you communicate that? Do you put it on Jira? Do you put comments on code? What's the workflow and technology?
We take a lot of screenshots, and we talk to the developers directly, and we tell them, so you did this wrong, and they say, no. And we're like, this is wrong, you see, it's not a best practice. And they say, okay, but I don't see the problem. So the problem here is to explain the developers, or afterwards the management, what is the impact of that vulnerability in their system. And you can say, oh, you don't have the all the HTTP headers you should have. And they say, and what? So you have to explain what are the attacks, the possible attacks. And this is the most difficult thing afterwards, because not everyone understands easily what's the impact of the vulnerabilities in their system.
So you just don't make any kind of exploitation or something like that? You just show this is bad?
No, we are not pen testers. So we check security by design.
Because for me, denial from developers is easy to deflect when you show, okay, it's broken. Here.
That's true.
That's the problem,
but for that we would need an infrastructure where we could make attacks and pen testing. So we get the source code. We don't take the development environment. Okay. So
how do you guys tackle things like race conditions and all those sorts of bugs that are usually hard to track and hard to explain? Because I worked in development for 8 years, and every time I had to explain some junior what a race condition was and how the hell someone could lift money from the website without doing the second factor pin, he went nuts, and I lost 4 hours of my life.
So our main so we don't, for instance, look for buffer overflows in the code. That is for that we use static analysis tools. If the client asks for it. What we do is we try to check whether the development team performs the secure development from the beginning of the system. So we advise on how to build the right thing, and not particularly particular bugs of the system. We can detect that, but that would make our analysis much more expensive. Sometimes we do that if you have unlimited time to look at the system and try to break all the doors, but that's not what we do. We are more practical, and we try to identify the threats on the high level, and tell them you have to take this into account. For instance, for authorization, they have to do the test, not us. So afterwards they do a pen test. And what happens most of the time is that the pen test detects the bugs that we detect, but they can't see the inside. So the pen test is more
focused,
more black box testing.
So one of the problems that you identified in the process was the requirements specification. What are the deliverables, or how do you define the security requirements? Because that's really hard, right?
That's really hard, and it depends on the system. So you should start with threat modeling. So you should start. You can use stride. So the methodology to identify threats in the system, and then you identify how to mitigate these threats. So it's a process.
So like there are classes of potential problems like input validation.
So what we exactly. So our models, we have a model. We are not doing this ad hoc, so we don't come up with ideas out of nowhere. So we have a model where we have guidelines of secure development, and we check these guidelines in the code. And
but once again, that's not the security specification or the requirement.
That's a requirement. Input validation is a requirement of the system, for instance.
So
it's a high-level requirement that can be split up in different types, sub-requirements. You are free to go.